We're going to talk a little bit about the unit circle and where it comes from, what it's used for, and hopefully demystify it a little bit and make it easier to understand. So first of all, what is a unit circle? All it is a circle with a radius of 1 unit. That is all that means when we say unit circle. We're just talking about a circle where the radius is equal to 1. It is nothing fancy. Why do we care about the unit circle? Well, we use the unit circle in trigonometry and in calculus to help us evaluate trig functions of common angles without the use of a calculator. So for example, if we need to know sine of pi over 6, we can use the unit circle to help us find that without having to use our calculators. So there's just a few things you need to remember. First of all are the special ratios for 45, 45, 90, and 30, 60, 90 triangles. So a 45, 45, 90 triangle means that 2 of the angles are 45 degrees, and of course it's a right triangle. And when we have a 45, 45, 90 degree triangle, the base and the height of the triangle, the 2 legs, are equal to each other. It's isosceles. And so I'm just going to call them A. And then the hypotenuse is always equal to A times the square root of 2. So whatever A is equal to, the hypotenuse is always going to be that number times the square root of 2. For a 30, 60, 90 triangle, the side across from the 30 degree angle will always be the smallest, and we're going to call that A. The side across from the 60 degree angle will be the other leg, which will be A times the square root of 3. And the hypotenuse is always 2 times A. So these are some things that you saw from geometry, but we're actually going to use them a little bit today. And so it helps to just understand these special right triangles so that we know where these values on the unit circle come from. All right, the other thing that we need to recall is SOHCAHTOA. So remember, SOHCAHTOA tells us sine, cosine, and tangent from the perspective of a right triangle. So you'll see it in the triangle there, we have the angle theta. And the side that is across from theta we call the opposite. The other leg is called the adjacent. And then the side opposite the right angle is called the hypotenuse. So we have some trig ratios here that we need to recall. So sine of theta is equal to the opposite over the hypotenuse. Cosine of theta is equal to the adjacent over the hypotenuse. And tangent of theta is equal to the opposite over the adjacent. Now, we are going to use these ratios on the unit circle. However, we're not going to really say opposite, adjacent, and hypotenuse like we do for SOHCAHTOA. So here's what we're going to do. We are going to call the opposite side y, and we're calling it y because notice it's vertical, so our y coordinates go up and down. We're going to call the adjacent x because it is horizontal. And then what's going to happen for the hypotenuse is that the hypotenuse is always going to equal 1 for the unit circle because the hypotenuse is actually going to be the radius of the circle every time when we start setting these things up. So just keep in mind that hypotenuse is the radius of the circle, and since this is a unit circle, the radius is 1 every single time. So what that means for us is that if we want sine of theta, we actually just need the y coordinate. And again, we'll see this in just a moment, so just hang in there. We haven't seen x and y yet, but we will. And cosine is just going to be the x coordinate. Again, not worrying about hypotenuse because it's just going to be 1 every time. And tangent is going to be y over x. So we're going to need those 3 things as we proceed. One other quick bit of information, what are radians? Radians are a unit of measurement for angles. So when you're measuring an angle, you can measure it in degrees, which is what you've probably done most of your life up until you started learning about the unit circle. radians are just another unit of measurement. So if you're measuring a length, for example, you could use inches or centimeters or feet. Those are just different units. It's the same thing. Radians are just a different way of measuring angles. Big idea here is that halfway around a circle is exactly pi radians, okay? So it's approximately 3.14 radians, but just keep that in mind as we continue through this. Keep going back to the fact that halfway around the circle is exactly pi radians. All right, so here we go. So when we have our unit circle, we are always going to start, at this point here, we're going to call 0, okay? So I'm just going to draw a line halfway through the circle, and that is going to represent our first set of angles. So this point right here is considered 0 radians, and we are going to start rotating around the circle in a counterclockwise direction. So as we rotate around in a counterclockwise direction, when we get halfway around the circle, we have gotten to exactly pi radians, 180 degrees. So we're talking about this angle right here is 180 degrees or pi radians. And if we continue to rotate around the circle in the same direction, by the time we get back to 0, we're at 2 pi. Okay, so halfway around the circle is pi radians, all the way around the circle is 2 pi radians, or 360 degrees. Okay, so what we're going to do is we are going to take that angle and we are going to cut it in half. And when we cut pi in half, we get half of pi. We get what we call pi over 2. So this angle up here at the top is pi over 2. And now we're just going to go ahead and we're going to count by halves, okay? So I'm starting here. I go around. This would be 1 pi over 2, 2 pi over 2, but it's reduced. Down here at the bottom is going to be 3 pi over 2. And as I continue around and I get back here, I get to 4 pi over 2, but it has been reduced. So if you just look at the circle as it is right now, you will see it is the half of the circle is cut into halves. Okay, so the whole circle is cut into quarters. But the pi, which is half the circle, is cut in half. What we're going to do now is we are going to take that half and we're going to cut the half in half. We're going to create quarters. And then I'm going to do it again on the other side. And now if you look at all of the lines, so we look at the blue, the orange, and the purple, you will notice that the top half of the circle is cut into 4 pieces. It is cut into fourths, okay? So let's start counting. So we're starting at 0. We move up this way. We get to 1/4. So we call that pi over 4. Pi is being cut into 4 pieces. Up at the top, we would have 2 pi over 4. Okay, so we have 1 pi over 4, 2 pi over 4, but it's reduced. Next one's going to be 3 pi over 4. And then we're going to keep going. This would be 4 pi over 4. 5 pi over 4 is down in that third quadrant there. 6 pi over 4 is straight down, but it's reduced. Next one's going to be 7 pi over 4. And all the way around the circle would be 8 pi over 4, but it's reduced. So again, we're just counting pieces here. We're counting 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay, so that gives us our fourths, halves, and wholes. All right, now let's take a step back for a second. We're still going to consider half the circle here to be pi. Okay, so that is not changing. And now what we're going to do is we are going to take pi and we are going to cut it into thirds. Okay, so I am going to cut the top half of the circle into 3 equal pieces. Okay, so if you look at the top half of the circle, you will notice that it is cut into 3 equal pieces. So let's go ahead and start labeling those now that we kind of have the idea of how this works. So this is still 0. This is going to be 1 pi over 3, 2 pi over 3, 3 pi over 3 is reduced, 4 pi over 3, 5 pi over 3, 6 pi over 3 is reduced. Okay, so we have all of our thirds in place. Notice that we skipped over that pi over 2 because halves are not part of thirds, right? So we took that top half of the circle, we cut it into 3 pieces. Next thing we're going to do is we are going to cut the thirds in half. And when you cut thirds in half, you get sixths. Okay, so let's go ahead and do that. So we're going to cut each third in half. And when we cut each third in half, you will notice that the top half of the circle is cut into 6 pieces. So what I'm going to do, I'm going to go around, I'm going to count by 6. So I'm going here, 1, 2, 3, 4, 5, 6. And I'm just going to label them as we go. So the first one here is pi over 6, 1 pi over 6. 2 pi over 6 is right here, but it's reduced. 3 pi over 6 up at the top can be reduced. 4 pi over 6 is over to the left. Next would be 5 pi over 6. 6 pi over 6 is pi. Next would be 7 pi over 6. 8 pi over 6 is reduced. Next we have 9 pi over 6, which we can reduce to 3 pi over 2. Next we have 10 pi over 6 is reduced. And lastly we have 11 pi over 6 before we get to 12 pi over 6, which would be 2 pi. Okay, so we took our circle, we cut it into thirds, top half of the circle into thirds, and then we took those thirds and cut them in half and created sixths. Okay, so when we put all of those things together on the same circle, this is what we have. All right, so again, remember that this is all based on half the circle being pi and us cutting it into equal pieces. Now, there are a few patterns that I want you to recognize before we start moving on. Notice in the first quadrant that all of your numerators are just pi. Okay, we have pi over 3, pi over 4, pi over 6. Notice in the second quadrant that all of the numerators are 1 less than the denominator. And they are 1 less than the denominator because you are 1 piece away from being to a full pi. In the third quadrant, all the numerators are 1 more than the denominator, okay? And again, they're 1 more because we just passed pi. We had 1 additional piece. And all of the numerators in the fourth quadrant are almost double. They are 1 piece away from being double the denominator, okay? So those are some important patterns because those are going to help us identify when we're given an angle. If I give you 7 pi over 6, you should right away be able to say, oh, that's in quadrant 3, okay? So it's just recognizing first quadrant has numerators of 1 pi, second quadrant has numerators 1 less than the denominator, third quadrant 1 more than the denominator, and fourth quadrant almost double. All right, now we are going to start labeling some coordinates. So think back to when you were a kid and you were learning how to plot points on a graph. We're going to just plot these 4 points here. We're going to write down what their coordinates would be. Now, remember, in the middle of our circle is the origin, right? Okay, so that's 0, 0 right there in the middle. If we move from the origin right 1 unit and we don't move up or down at all, our coordinates for that point are 1, 0. We went right 1 unit, remember the radius is 1, and we didn't move up or down at all. If we go up from the origin, we haven't moved left or right at all, we have just moved up. So that would be the point 0, 1. If we move left from the origin, we get to -1, 0. And if we move down from the origin, we're at 0, -1. Okay, so there should really be nothing confusing about those 4 coordinates. That's just basic plotting points. If you go right 1 or up 1 or left 1 or down 1, those would be the coordinates of those points. Okay, so remember, the x-coordinate is telling us cosine and the y-coordinate is telling us sine. So we have just identified sine and cosine for 4 angles on our unit circle: 0, pi/2, pi, and 3 pi/2. Okay, so what we're going to do now is we're going to start finding those coordinates for some other points on our unit circle. And the first one we're going to do is this point right here at pi/4. And remember that we have a radius. Okay, so there's our radius. And that radius has, a length of 1, okay, because it's a unit circle. All right, and we are going to actually create a triangle. So I'm just gonna drop a line down here, and I'm gonna create myself a nice little right triangle. And that is a 45, 45, 90 triangle. Okay, so there's our right angle. So remember what I reviewed in the beginning said that if you have a 45, 45, 90 triangle, your ratios are A root 2. So what we know right now is that 1 is equal to A root 2. And if we know that 1 is equal to A root 2, we can solve for A. Okay, so if we divide both sides by root 2, we get that A is equal to 1 over root 2. And then, of course, we like to rationalize things, get that denominator, get that square root out of the denominator, right? And so we end up with A is equal to root 2 over root 2. Okay, so that's this here and this here. So if we're thinking about, again, moving from the origin and plotting points, if we start at the origin and go over root 2 over 2 and up root 2 over 2, then the coordinates of this point at pi/4 would be root 2 over 2, comma root 2 over 2. Okay, and again, we figured that out because we had a 45, 45, 90 triangle with a hypotenuse of 1. Okay, now, it turns out that this exact triangle appears again over here. Notice that it's the exact same triangle, it has the exact same dimensions, and the only thing that's changing is that we move to the left, okay? Our x is going to be negative, and so the coordinates at 3 pi/4 are going to be negative root 3 over 2, negative root 2 over 2, comma root 2 over 2, okay? We again have this triangle down in the third quadrant. Here's our hypotenuse, our radius, here's our triangle, and now our coordinates, of course, will have the same dimensions. Our triangle will have the same dimensions, but now x and y are both negative. And no surprise, we have the same triangle in the fourth quadrant, same dimensions. This time, our x is positive and our y is negative because we went right and down, okay? So again, those are our sine and cosine values now for all of the pi/4 angles. Pi/4, 3 pi/4, 5 pi/4, and 7 pi/4. All right, let's take a look at pi/3. Oops, I'm having some trouble here with my pen, sorry. Okay, so what we're going to do now is we're going to create a triangle using pi/3. Okay, so here's My point pi over 3, I'm going to draw it to the origin. Let me actually do that with a highlighter so we can see it a little better. And I'm going to drop it straight down and make a triangle. And I have created a 30, 60, 90 triangle. Okay, so remember, pi over 3 radians is the same as 60 degrees. So we saw previously that the short leg would be called A, the longer leg would be A root 3, and the hypotenuse would be 2A. And again, we know that this hypotenuse has to be equal to 1 because this is a unit circle. The radius is 1. All right, so we know that 1 is equal to 2A. And so A must be equal to 1/2. Okay, divide both sides by 2, we get A is equal to 1/2. So our hypotenuse is 1, A is 1/2, and then this guy must be root 3 over 2. 1/2 times root 3 would be root 3 over 2. Okay, so it was a little bit less work this time, right? So our x coordinate is 1/2, and our y coordinate is root 3 over 2 when we plot that point right there. So let's go ahead and write those down. So we get 1/2 comma root 3 over 2. Sine and cosine for pi over 3. Now, just like before, we have these repeated triangles all over. So at this one, that wasn't a very good drawing, sorry. Okay, so this angle is going to have the same coordinates. This angle down here in the third quadrant will have the same coordinates. This angle in the fourth quadrant will have the same coordinates. The only thing that's going to change is what's negative. Okay, so this is going to be negative 1/2 root 3 over 2 because we moved left. This one, they're both going to be negative because we moved left and down. And this one, 5 pi over 3, is going to be a positive x but a negative y. Okay, but my coordinates did not change at all. Now, the cool thing is, and let me erase some of this stuff now. The cool thing is that the 30, 60, 90 triangle appears again at pi over 6. Oh, need my highlighter. It is just rotated. Okay, so if we draw a triangle here, you will notice that it's the same triangle, it's just flipped on its side. So we still have a hypotenuse of 1, but now the shorter side is our y coordinate, and the longer side is our x coordinate. So those coordinates that we just found are just going to be flipped. Okay, and we're going to go ahead and we're going to fill those in for all the pi over 6s. So this guy here, this guy here, and this guy here. Those are all going to have the same coordinates, root 3 over 2 comma 1/2, except possibly negative. Okay, and now we have completely filled in our unit circle. So if you were writing this down as we were working, just go through, pause, make sure everything looks right. All of your angles that have the same denominator should have the same coordinates. Okay, so double check that right now. All of the pi over 3s are the same. All of the pi over 4s are the same. All of the pi over 6s are the same. Okay, so that's what makes the unit circle actually not that hard to memorize, is that if you know the denominator, then you know the coordinates. Okay, few other things before we move on and look at a couple examples. The only things that you actually have to know are what I'm going to highlight here. If you can memorize these highlighted parts, then you know the entire unit circle. That's all you need. Those parts right there. So if you can memorize those parts, That is all you need to know to memorize the unit circle. A few other things. Notice in the first quadrant that the numerators, so let's look at the numerators go 1, 2, 3, 1, 2, 3. Really not hard to memorize 1, 2, 3, 1, 2, 3, right? Just remember, you start at the top, you go down 1, 2, 3, and then you shift over and go up 1, 2, 3. All the denominators are 2, so there's nothing fancy about that. All of the numerators have square roots. We just don't see it around the 1 since square root of 1 is 1. But very simple patterns actually to remember. One more thing before two more things. In the first quadrant, all of our trig functions are positive. So we write A for all. They're all positive. In the second quadrant, sine, so I'm going to write S for sine. Sine is positive, and so is its reciprocal, okay? So cosecant is its reciprocal. I'm not really focusing on the reciprocals in this video, but just keep in mind sine is positive there, so is its reciprocal. In the third quadrant, tangent is positive, so is its reciprocal. And in the fourth quadrant, cosine is positive. All right, so they're all positive in 1. Sine is positive in 2, but the other cosine and tangent are negative. Tangent's positive in 3. Sine and cosine are negative. Cosine's positive in 4, where sine and tangent are negative. And we can remember that using all students take calculus. Okay, so all students take calculus helps us figure out what trig functions are positive or negative in which quadrants. The third thing, or the last thing rather, that I want to mention before I move on is tangent. We haven't talked about tangent a whole lot. Remember that I said in the beginning that tangent is equal to the y divided by the x. So you're going to have a little bit of work to do if you have to figure out tangent. The unit circle explicitly gives us sine and cosine, but it does not explicitly give us tangent. So tangent requires division. And I'm just going to write down these tangent values. Some people think that they're worth memorizing. They're actually not that hard to memorize. But for pi over 3, tangent is root 3. For pi over 4, tangent is 1. And for pi over 6, tangent is root 3 over 3. So I remember those by looking at the denominators. So a denominator of 3 goes with root 3. A denominator of 6 has root 3 over 3 because 3 plus 3 is 6. That's just how I remember it. Tangent is 1 at pi over 4 because the x and y coordinates are the same. Okay, so if you divide something by itself, you will, of course, get 1. You don't see tangent as often as sine and cosine, but just keep in mind tangent is the y coordinate divided by the x coordinate, and I have simplified them there for you in green. Okay, so what is the point of all of this? What are we actually going to have to do? So if you know the first quadrant, and by first quadrant I mean the things that I had highlighted in yellow previously, so we actually also need pi over 2 pi, 3 pi over 2, and 0. But if you know the first quadrant, you're set. That's all you really need. When you are given an angle, you're going to look at the denominator to determine the coordinates. All of the denominators of 3 have the same coordinates. All of the denominators of 4 have the same. All of the denominators of 6 have the same. So the denominator really gets you set up with your coordinates. Next, you are going to compare the numerator with the denominator to figure out the quadrant. Okay, so remember I mentioned earlier, in the first quadrant, all the numerators are 1. In the second quadrant, all the numerators are 1 less than the denominator. In the third quadrant, they're all 1 more than the denominator. So those patterns are important. And then, of course, remember again, you might need to find tangent or the reciprocal functions, but I am focusing on sine and cosine here. All right, so let's do this. In order to do these problems, this is all you need. So at 0, we're at 1, 0. At pi over 2, 0, 1. At pi, negative 1, 0. And at 3 pi over 2, 0, negative 1. And then we have pi over 3, pi over 4, pi over 6. And our numerators go 1, 2, 3, and then backwards 1, 2, 3. And that's not something that you have to write out every time. You should really practice visualizing it in your head. So here's what we're going to do. Let's pretend that we are supposed to find sine of 2 pi over 3. Notice that 2 pi over 3 is not on that little image that I just drew for you there, okay? So first thing we're going to do is we are going to look at the denominator. And the denominator is 3, which means we're going to use the pi over 3 coordinates. So I'm going to write them down. Next thing I'm going to do is I'm going to compare the numerator with the denominator. So since the numerator is 1 less than the denominator, that means that we are in quadrant 2. And in quadrant 2, the x-coordinate is negative. So I'm going to put a negative there with that 1/2. All right. Now, the problem has asked us to find sine of 2 pi over 3, and sine is the y-coordinate, and so we have our answer. Let's look at the next one. First thing again we're going to do is look at that denominator. It's a denominator of 6, so we are going to write down our coordinates for pi over 6. Next, we are going to compare the numerator with the denominator. It is 1 more, which means that we are in now quadrant 3. And x and y are both negative in quadrant 3. Cosine is the x-coordinate, and so we write our answer. Cosine of 7 pi over 6 equals negative root 3 over 2. Okay, let's do another one. Sine of 7 pi over 4. Look at the denominator. Write down the coordinates for that denominator. So the pi over 4s are root 2 over 2. Root 2 over 2. Then we compare. 7 is almost double 4. Almost double is in quadrant 4. We're almost to 2 pi. And in quadrant 4, y is negative. And sine is the y-coordinate. So sine of 7 pi over 4 is negative root 2 over 2. And last one for today. Let's see. We're going to look at that denominator. It is 6. We're going to write down the coordinates for pi over 6. We are going to compare the numerator with the denominator. It is 1 less. That means we're in quadrant 2. In quadrant 2, x is negative because we have moved left. And cosine is the x-coordinate. So cosine of 5 pi over 6 is negative root 3 over 2. All right, that's all there is to it. I hope this was helpful. Go study your unit circle, memorize that first quadrant, and you'll be good to go.